Hello everybody, today I'm going to explain the solution to the third problem from the 2025 February contest, USACO February contest in the Silver Division, the problem transforming pairs. In this problem, we are given a very mathematical kind of exercise on which we have two piles, which at first have A bales and B bales, and we need to use certain operations in order to get them to become equal to C bales and D bales. And in order to do that, we have to either make one of them increase by the value of the second one, or the other way around, to make the second one increase by the number in the first one. And for each of these t-test cases, the values are quite big, so we now want to see the minimum number of operations we can do to fulfill this kind of task, or to print -1 if it's not possible. Now, a very common technique when it comes to this sort of mathematical problems is to think at the relevant stuff that we have in the statement. And in a way, if we think about these sort of operations, by increasing the amounts by the other value, in a way, it reminds us of the GCD algorithm, because if you remember the Euclidean algorithm for greatest common divisor, you also kind of have to do something like this, where one of the variants of this algorithm is to always subtract the smaller number from the bigger one. And this sort of intuition leads us to think, what about instead of having to increase the numbers from A and B to C and D, to try to decrease them from CD to AB. And now these operations are now mirrored, so obviously we can now subtract always from the larger number the smaller number. So again, we have achieved a very important simplification. And with this sort of simplification, we can now go on and try to compute quickly the number of operations we need. Because if we look at the GCD algorithm I mentioned, so basically one GCD algorithm, this is very slow normally, but it can be optimized, is while A is different than B, if A greater than B, you subtract B from A, otherwise you subtract A from B. So again, a very similar GCD algorithm. This can obviously be further optimized to the Euclidean algorithm, but the main point about this algorithm is that it gives us the main motivation to think at a strategy that can help us solve the problem without much complications. And now all we have to do in order to get to implement this problem is to be very careful at dealing with some basic cases. Obviously, we want both of the numbers from the right to be at least equal to the numbers from the left. And very importantly, the GCDs also have to be equal, because if you have a GCD which can't really help you achieve much in terms of the operation, then there is not much of a point in getting the answers done. So this is also something very important to take care of. And now in my implementation, you will see that I had to deal with quite a few cases in order to reach the final answer, as you will see here. Because at first I had to make sure that the target must not be larger than the start, and also the GCD is invariant under these subtractions. So basically, no matter what we do, the minimum we can subtract is the GCD of these numbers. You can't subtract something smaller. And then here, as you see, we can have this sort of while loop, which works in a very similar method to the while loop we would have for the GCD. But again, we will do this in the opposite way. If at any point we overshoot and we achieve the smaller number on either side, then it's not gonna work. Otherwise, in order to avoid having to write the same cases twice, I swapped the numbers. If I always assume that the second number is smaller than the first one. So if this never happens, if this doesn't happen, I just swap them. And here it depends a lot on whether the whether the C is greater than A or not. Because if we have to subtract from the first number, then we can perform the maximum number of subtractions. So again, we reverse the Euclidean algorithm. And in a very similar manner, we proceed also with the case when the second number is greater than its counterpart in the other array. So as you can see, the methods themselves are very complementary one to another, because all we have to do is to make sure that when we perform these mathematical operations, we arrive to the answers without much of a difficulty. And obviously now we want to make sure that we never went into a fault and into a faulty case, and that we achieved equal values in the end. If this happened, we just print the number of operations, otherwise we print -1. So again, this algorithm reflects very well the GCD algorithm, and it also gives us a runtime of roughly log n, which is very good given that we have to perform a lot of test cases, and also the constraints are very high. And this is also in team with other mathematical style problems that occurred in the past in USACO. For example, there was the bakery problem not long ago, and also other similar problems. If you enjoyed watching this video, please like the video, subscribe to the channel, and press the bell button in order to stay tuned whenever I have any sort of new video, be it for USACO or for other competitive programming competitions. In addition, if you have any suggestions on how can I improve my videos, I would be delighted to hear them in the comments, as I want to reach out to each and every one of you who is replying and gives me relevant things to comment on. Last but not least, if you or someone you know is interested in working more closely with me in order to improve their USACO results, be it for the US Open Contest or for the long term in the next season, please check out my website and ways to join my tutoring program. Until the next time, good luck in the remaining contests for this season, stay tuned, and see you next time. Cheers!